Young people, welcome back. Bearded math brother in the house, ready to take care of chapter 4, lesson 7, inverse linear functions. The learning objective: find the inverse of a relation. Second objective: find the inverse of a linear function. All right, so guys, we are going to be dealing with some stuff that may and will and does look, sound, and just no type of math you've ever done. And I'm just glad you're here to get a little assistance with it. So let's get started. Boom. All right, guys, what do you think? Pretty handout? All right, let's go. A couple of tables and graphs on it. Looks like we have to find the inverse of each relation. So guys, inverse literally meaning, kind of like the reciprocal where you flip it, right? So the inverse of adding and subtracting, the opposite, right? So the inverse of xy would be yx. That simple. I'll say that again. The inverse of xy is yx. So I need to write it as -1, -9. The next one, -4, -7. And so on and so on. So just getting the simple done first, because of course it is going to get a little bit more challenging, but just knowing that when they want you to do the inverse of the relation, well, flop it. That's it. So whether they give it to me in a table or they just give it to me as a list, it doesn't matter. I just know to swap my x and y to get the inverse. Number 2, nothing changes, guys. No need for the extra arrows. So boom, boom, boom. Pop, pop, pop. And if I need to slow down, because again, if you've been in one of my videos, you know I will and can make a mistake. So just knocking this out, guys, the top portion of this lesson, just knowing to swap my x and y. And now, guys, I believe that is it. And we move on to the next portion. And the next portion is just taking it a step further with the coordinate plane. Knowing that if you can do it writing it, you can do it when you graph it, correct? And whether they give it to me as a list here, or they give it to me as a table, this could be more challenging, but there's nothing different. 4 more, and this time, guys, as I read the first coordinate, -3, 2. Swap it, right? As I read the next coordinate, -1, 8. Swap it, 8, 1. And then 1, 14, 14, 1, 3, 20, 23. So literally do that, and you did it correctly. We call those what are they? Grouping symbols. So definitely recognizing that I want to follow their lead, of course, when writing it out. So for 5. -3, 5, -9, 2, -15, -1, -21, -4. And then, of course, close your grouping symbols, because that could be your set, right? It's a set of coordinates. Number 6, again, nothing new, 6, 4, 1, 3, -4, 2. And the last one looks like we got a beautiful -9, 1. What is that? Why is it beautiful? Because it's here with us. If you're here with us, you're beautiful. Then 16, -1, 12, -2, 8, -3, and 4, -4. This is when I used to crack up kids like, well, I didn't do it. I didn't get it. You couldn't swap 2 numbers? Like, it's the concept. The skill is flipping it. I understand the concept. Concept is if it's x and y, the inverse of that, right? Wow. So here we go. This is what I'm talking about. Graph the inverse of each function. So they gave me a function, so a list of points and connect those points and whatever, whatnot. So what I'm going to do now, guys, is recognizing where. And when I say where are the coordinates that I can take the inverse of? So one of those coordinates, of course, is the y-intercept. I can pull an x-intercept, hopefully, right? But I can also use slope, kind of just count, kind of see where it's at, up to the right, down to the left, right? Just get other points. And those other points that I'm getting, looks like -10, what's that, 8? That's good. Being careful too, guys, that you recognize your axis doesn't count by ones in this one, it counts by 2. So just being aware of what's happening. And there's the third point I'm going to use, and that is, as you can see, +10. And that is the x-intercept. So going back to our original knowledge and stuff, y-intercept, x-intercept. Right. So now, guys, flopping. All right, so now instead of 0, -4, I got -4, 0. Instead of -10, -8, -8, -10, and of course the last one, 0, 10. And plot those points, right? I believe I need to plot those points. There we go. And now this is where you'll see it and you'll be like, really, that's the inverse? Like, yeah, it all depends on how the line is formed, but when I get those 3 new coordinates, there they go. Right? There we go. That looks like I can get it. So this should go ahead and, I don't know why, but I want to get this class 0, -10. I'm sorry, 0, +10, -8, -10, which should be way down there. And I don't know what's coming. I know it's coming. Here it comes. So, thinking about making sure I'm getting it, guys. Sometimes I let it play, and that's why we'll sit and we'll watch. And sometimes I gotta learn how to navigate these nifty devices I get to play with, right, to make these cool videos. But, boom, bang, pow. Next one, same thing, just a few points. Looks like one there, one there, one there. And that's what I mean, guys, by using the slope. You can recognize from that top green, to the right, 1, 2, 3, down 1, 1, 2, 3, down 1. So accurate points for that function, that linear function, and those points are 0, 6. Again, counting by 2s on the axis, right? -6, 8, and of course, +6, +4. So we're gonna go ahead and take the inverse of those 3. And of course, first one would be 6, 0. Second one, of course, now would be, take a good, 8, -6, and the last one, of course, being 4, 6. And graphing, all right? And again, guys, when I take a look at what we've got, I got 1, 2, let's get a third. And of course, now that I got all 3, get a straight edge. And this is probably what's taking so long because now I recall that. And if you do notice, guys, the slope starting from the bottom right, you go up 1, 2, 3 to the right one, 1, 2, 3 to the right one. I'm sorry, to the left one, but accurate, right? Bam. Last one. Arrows on the end, of course. But for number 10 now, guys, we're gonna do the same thing. Pick your points. Again, y-axis, not very helpful. X-axis, not very helpful. But that point is very obvious and easy to see. I can plot it out, write it out, right? So, -4, 2, right? Next one, -6, -6. And you're gonna recognize what happens with that one, guys, because with the X and Y being the same value, when you swap them, they're still the same, right? And one more point, just to keep it clean as I can. No, just 2 points. I could use the slope again, but I guess I said, nah, I'm happy with 2. 2 is all we're gonna do. 2 is what we're gonna do. Notice how that red point for the inverse function is literally on top of the original function, because, like I said, -6, -6, when you swap those, it's still gonna be in the same location. All right, guys, put the arrows on the end, and I feel good about it. What I feel good about, guys, as I get a opportunity to pause. In a second, we're gonna get into some uncharted waters, and but it's nothing that we can't handle. So the first portion over here, guys, was you being able to accurately graph a coordinate, right? You recognizing what's X and what's Y, swapping them, plotting points, connecting dots. Next, guys, we're going to use some of those algebra skills that you learned in some of the earlier chapters. So, as we let this ride out, because this, of course, is good, but it's not as good as what's coming up. So let's get it out of here. And I think we're gonna need as much room as we can get. So, and here we go, guys. So what I mean by we're gonna need as much room as we can get is find the inverse of each function. So now that it's not a linear function that's graphed, it's on me now to take the steps to accurately write it as the inverse function. So real simple, guys, found this on the net, World Wide Web. So step one, you're gonna write out the function as y. So, and we do that, f of x is the same as saying y. So instead of saying f of x equals 8x minus 5, we're gonna say y equals 8x minus 5. Simple enough, guys. So then we're gonna swap the x and y. Remember we were doing with the 2 points? Boop, boop. Well, here we still have those two values, x and y, not 2 points. A point has one value. I'm sorry, 1 point has 2 values, the x value and y value. So we're swapping them before this, guys, we absolutely swapped them. So the next thing, as you can see, I'm writing it out because I like how I said it. Make y the subject, basically solve for y. So by solving for y, we got a 2-step here. First step, add 5 to both sides, get rid of the constant. You want the x term by itself. Y term, sorry. 8y. Now that it's by itself, we gotta get y by itself, so we divide both sides by 8. And here's that little thing where if you haven't done it with me before, guys, I'm happy with that. X plus 5 divided by 8 is what y is equal to. You just solve for y. So now the last step, this is where I'm talking about uncharted waters. Just being able to read it is pretty fun. So y is equal to x plus 5 divided by 8. Well, remember, guys, we were writing the inverse function. So the function of x, the inverse function of x. That's what that little negative 1 is there. So, we're done. We gotta do it again. And this time, guys, nothing different except the linear function, 6 parentheses, x plus 7 parentheses close. So again, just recognizing that the function of x is the same as y. Y is equal to 6 times the quantity x plus 7. You're gonna swap your x and your y. All right, so replace that y on the left with the x in the parentheses. And easy enough to solve for y this time, undo multiplying by 6. So we divided both sides by 6. Now it just says, x divided by 6 is equal to y plus 7. Well, guys, y still needs to be by itself, so you subtract 7 from both sides, and guess what? Now you got y by itself on the right side. So you're good. X divided by 6 minus 7 is equal to y. That is your inverse function. So a couple little mini steps with your final step. And this is where, again, the function of x, the inverse function of x. F of x, the inverse function of x is equal to x divided by 6 minus 7. And that's it, guys. So it takes a little bit of understanding. When I say understanding, you gotta know you're swapping your x and y. You know you gotta divide both sides by a coefficient. And sometimes that might be the PLC, your point of confusion. Well, let's take care of 13 here. Again, first step, recognize that the function of x is equal to 3/4 x plus 9. We're gonna rewrite that function as an equation. Yeah, just y equals 3/4 x plus 9. Looks like our traditional linear equations, right? Since we're writing the inverse function, we're swapping the x and y. So now instead of saying y equals, we're gonna say x equals. And of course, solve for y. We've got our traditional 2-step here. With a little bit of fun, recognizing the coefficient is 3/4. But subtract 9 from both sides, easy. Negative 9 plus x, or x minus 9, is equal to 3/4 y. Here's where, do you know the reciprocal? So to get 3/4 away from my y, I'm gonna use the reciprocal 4/3. See it there in red. Top times top, bottom times bottom. You get 12 divided by 12, so that's what? 1, so 1y. But on the other side, this is where you gotta get it, guys. When I say you gotta get it, what's happening? Well, the top is 4 times the quantity x minus 9. The bottom is 3 times 1. So that's it. Keep it like that. The inverse function of x is equal to 4 times x minus 9, all divided by 3. And there we go, guys. So again, definitely go back, watch that last 30 seconds. Go back, watch that last 2 minutes. Pause it, look up. What's going on? So 13 there, guys, and I believe 14, 15, and 16 are all yours. So guys, remember, I'm not going anywhere. If you would like some additional practice with some of our handouts that are not getting finished, I'll go ahead and put it in the comment. Definitely ask me some questions. I'd love to get to them. Because if you understand the concept and you understand the skill, BMB got you. Just let me know where your POC is. See you next time, guys.